This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Developers, take your marks. It's time to upgrade your data platform to InterSystems Iris. It's time to deliver complex mission-critical applications in the fastest route possible. It's time to use any data from any source. It's time to embed analytics and create interactive user interfaces. So what are you waiting for? Choose your language, choose your tools, choose your environment. Collaborate, build faster, and deploy more efficiently. Done and done. Tomorrow's next breakthroughs are waiting for you today. InterSystems Iris Data Platform, the fastest way to build applications. Ready, set, code. Start coding for free. Visit intersystems.com/try to try Iris.
Rich Harris is the creator of the open source project Svelte. For work, Rich is a graphics editor at the New York Times investigation team. Prior to the New York Times, Rich worked at The Guardian for several years working as an interactive developer and editor. In addition to Svelte, Rich has also authored the open source project Rollup, a JavaScript bundler similar to Webpack and Parcel. Rich, thanks for coming on to Software Engineering Radio.
It's good to be here. Thanks for having me.
Absolutely. So let's kick things off. At a very high level, what is Svelte and what sparked its creation?
So I'm sure that some listeners of this podcast will be familiar with projects like React and Vue and Angular and things like that, which are essentially ways of building user interfaces in a more declarative way than we used to in the old days of things like jQuery. And these are very popular. They're kind of the standard way that people build applications nowadays. A few years ago, I was using a similar framework, a predecessor to Svelte called Reactive, to build interactive web applications in my day job at The Guardian. And I was becoming increasingly concerned about the amount of JavaScript that we were sending down to the browser, particularly because a lot of our readership was shifting at that time from desktop to mobile. And frankly, a lot of these front-end frameworks, they are too big. They involve too much JavaScript. And so started thinking about what a potential solution to that could look like. And after some conversations that I'd had that year, I've been thinking about whether or not it would be possible to take the same declarative code that we use to build applications using component frameworks and kind of compile that down to this optimized vanilla JavaScript form. So in essence, while you're writing the high-level code that is very easy to read and write and understand, the compiler is turning it into the kind of direct DOM manipulation that browsers are very efficient at. And it turned out to be a pretty successful experiment. We managed to get our JavaScript payload sizes down quite substantially by using this technique. And it kind of went on from there until last year, in I think about April of last year, we decided to overhaul the developer experience as well. So now we have this very small, very fast form of JavaScript application. People seem to agree is a really quite nice development experience. So that's what it is. It's a way of building interactive web applications without penalizing the user with big JavaScript payloads or slow DOM updates and any of the other problems that have historically affected some applications built with these frameworks.
So compiler as a framework is a pretty unusual way of doing things on the front end. So why the need to go compiled?
Well, the way that these things traditionally work is you will write your application declaratively, and then you will take that declarative form and it will pass over to some library, which then has to kind of interpret it and figure out what to do with it. And so classic example would be the virtual DOM technique that's found in libraries like React. The way that a React application typically works is, conceptually at least, you're re-rendering the entire UI on every state change. And I should stress that that's not actually what's happening, because there are all kinds of optimizations so that you're only ever updating a subtree of your application in most cases. But essentially, you're kind of re-rendering the world from scratch, and then you're handing it off to this engine, which then has to figure out what changed from the last time that happened. And so it goes through this diffing process, figures out what on the page is now out of date, and then it makes that change on the page. And that works for the vast majority of applications. That is fast enough. But there are costs to that. Number one, you have the diffing process itself, which is not free. And we've seen all kinds of interesting strategies to mitigate the cost of that diffing. Number two, in order to get that virtual DOM structure, you need to rerun a lot of user code. And that's actually where a lot of the performance gotchas tend to be, because it's really easy to write code that isn't all that well optimized. If you have something that is this kind of statically analyzable form, then you actually don't need to run user code nearly as often. And then thirdly, in order to actually do that reconciliation, you need to have something that is capable of doing that diffing process, which means that you're shipping that JavaScript with every single application that uses those frameworks. And so by taking the compiled approach, you can kind of chip away at each of those problems individually.
And so at what step in the build process does this all happen? So you've got your code, you're ready to start compiling it down. Walk me through the process from saving the code to getting it to the browser.
So you'll write your application into a series of components. We use a .svelte extension typically, and a Svelte file is kind of a superset of HTML. So you have your markup and you have some script that defines the component's behavior, and you have some styles which define the component styles and their scope to the component, but that's something that we can probably come back to. And you just import that file like you would import any other JavaScript module. So in the same way that you might do import foo from /foo.js, you can do import app from /app.svelte. And then what your JavaScript bundler does at that point is, because you've used the Svelte plugin with your Webpack config or your Rollup config or your parcel config, it knows that when it encounters a file with a .svelte extension, it needs to hand the code off to the Svelte compiler, which will turn it into a JavaScript module. And so as far as your bundler is concerned, it's just like any other JavaScript class.
Babel is a source-to-source compiler, also known as a transpiler for JavaScript's latest features. So is it similar to Babel in terms of how it compiles down the code?
I think there probably are a lot of similarities in the techniques that are being used. There are definitely some differences as well. Svelte is not using Babel under the hood, it's using its own compiler. It has its own HTML parser, and it uses a JavaScript parser called Acorn and a CSS parser called CSS tree. And it takes your input code and it hands it off to those three separate parsers, and then from that we've got this abstract syntax tree. And then there's a process of walking that abstract syntax tree and understanding all of the different parts of your application, understanding how the styles relate to the markup, understanding what kind of variables there are in a component, which things could change, which bits of state we have that could possibly affect what needs to get rendered. At the other end of that, we have the JavaScript that gets generated. And it's, as I say, it's not exactly the same process that Babel uses, but I imagine that it's pretty similar. Not that I'm intimately familiar with Babel's source code, because that's quite a chunky project that I haven't spent a lot of time getting my hands dirty with.
So would they actually be considered alternatives to each other?
Not really, no. Babel is a very extensible system, and I think you probably could write something akin to Svelte within the Babel ecosystem, but Babel is really more focused on fairly small syntax transformations to take code that targets the newest versions of the JavaScript spec or the TypeScript spec and compiles it down to something that can run in basically every browser that people are using. Whereas Svelte is doing something different. It's taking your declarative code and it's turning it into something that is a completely different type of program. It's turning it into imperative JavaScript. So even though you can kind of look at a piece of markup in a Svelte component and you can trace it to the JavaScript that ends up getting generated by the Svelte compiler, it's not like we're just doing a little bit of syntax transformation here, a little bit of syntax transformation there. We're actually completely rewriting the code, or not even rewriting, we're generating a program from scratch based on the blueprints that you, the architect of the program, have provided.
So this means that you're actually transforming the code into imperative JavaScript, completely rewriting it. How do you make the code imperative?
It's a good question. So it probably helps to think about how you would write an application 10 years ago if you're approaching the same problem, but in the pre-framework era, and you're using vanilla JavaScript. So let's say we want to build a button that increments a counter every time you click on it. You might do something like var button equals document.createElement and then pass it the string button. And that gives you your button element. And then you might have a variable representing the count, var count equals 0. And then you might have an update function and just call it function update. Inside that, you might say count plus equals 1, and then button.textContent equals, and then the count variable. And then finally, you just need to do button.addEventListener and then pass it the update function. And then all you need to do is mount that button element to the body of your application, and you have an interactive clicky button thing. And it works. That is the process by which you update something on the screen. What Svelte is doing is essentially trying to recreate the code that you would write by hand in that situation, except that rather than writing all of that stuff out by hand, you're literally just writing the markup for a button, and then you're putting inside the button an expression that represents the current count, and then add an event listener declaratively, and Svelte will turn that into button.addEventListener and so on. In that way, it's able to basically get the same performance characteristics that you would generally get if you're writing these things by hand.
All right, so you're basically making in the manual process of event listening and event delegation that would normally be done in vanilla JavaScript, and you're doing that through the compiler, because that's the area where people, are they messing it up the most, or is it just the rote pieces that are sub-optimized? It seems like for, if you have HTML, CSS, and JavaScript, the main actual interactive JavaScript you're writing in Svelte probably isn't being optimized that much. It's more the stuff that's on the HTML layer that you're trying to optimize. Is that a fair assumption?
It is, yeah. So when the thing that people found in that era when we were building stuff with jQuery was that it's really easy to write buggy code that way. And we even have a phrase for it, spaghetti code, because you can't think of your application in a very holistic way. You have to sort of trace the possible code paths and think about how the user interacting with the application can result in a particular code path being taken. And so you're thinking not just in like the two-dimensional terms of what the code looks like on screen and what the output is going to appear as, but you're sort of thinking in this third dimension, which is time as the user interacts with the application. And it's incredibly difficult, and even experienced programmers get this stuff wrong all the time. A compiler doesn't have that problem. It allows you to think in that sort of two-dimensional way of just, this is what the application looks like for a given state, and then it does the hard work of making that a bug-free experience. The other thing that people found was that it can be quite difficult to write vanilla JavaScript applications in a way that is performant, because it's easy to get into a situation where you're over querying the DOM or over updating the DOM because you don't want to keep track of the very small state change deltas each time. So you tend to sort of just throw a whole bunch of new state at your application and kind of let it figure itself out. And again, a compiler can be a little bit more conservative than you would typically be if you're writing the code yourself. So I think it helps to think of Svelte as kind of an assistant in a way. Like instead of, you're no longer the plumber and the electrician, you're the architect. So you can think about what the house should look like without having to worry about where all the cabling is having to go. And because of that, you're spending your cognitive time at a place where it's better suited.
Right. So when you think about creating a click function, all you have to think about is, I'm adding this click property onto this tag in Svelte. Svelte is smart enough to go, okay, I see a click property. I'm going to handle the event delegation, piping everything up together, so you no longer have to worry about that.
That's exactly it. Yeah. You just need to focus on what the application looks like for a given piece of state and how that state changes, and everything else flows from that.
And most frameworks rely on Babel to handle language upgrades. How does Svelte handle this?
So we don't really get involved in that stuff. Svelte generates modern JavaScript. If you want to use something that is beyond modern JavaScript, then you might need to pre-process your component code. If you want to target older browsers, then you might need to post-process the output of the Svelte compiler. But Svelte is basically targeting modern browsers with the option to transpile for older browsers if you need it. And so we don't actually have Babel as part of our default project templates. That's something that people can bring if it's something that they need for their user base.
Okay, so you can actually stack the two on top of each other and you'll still get the optimized output. Okay, changing directions a bit, I want to compare Svelte to the other sort of big frameworks in the front-end world, Angular, Vue, and React. Starting with Angular, with Angular, it's backed by Google, it's huge, it's bloated. The upside is that you've got everything but the kitchen sink. The downside is that because you have everything but the kitchen sink, you might get more than you need and it can be very large and slow. So are you competing in the same space given that you are a full stack, you support HTML, CSS, JavaScript, and all of the interactivity that comes with it?
We're definitely competing in overlapping spaces, I think. And actually, I don't like the word competing because there's room for all of these different projects. And Angular it certainly has a reputation that you describe of being a little bit, let's say, soft around the edges. But the more recent versions, and particularly the next version, which I think is going to be, I think it's Angular 9 maybe, I haven't totally kept track, is taking a pretty similar route to Svelte of taking your templates and compiling them into a more optimal form. So because of that, Angular apps are going to get smaller, they're going to get faster, and they're already, I think they're pretty performant in their current state. But yes, you're right, Angular has a whole bunch of extra stuff with it, like you get internationalization out of the box, and you get like a very opinionated testing story, and you get HTTP helpers and all sorts of things that Svelte is not concerned with. Svelte is designed to be just the UI and just the state management that you need to build a UI. And everything else is kind of left to you as the app developer to figure out if it's something that you need, and if so, to get the version of that thing that best suits your app. Because I don't think that a team as small as Svelte could possibly have the best possible answer to all of the questions that a framework like Angular attempts to answer.
Does Svelte have a modular plugin system so that if you are missing something that Svelte can't provide, that you can find it somewhere else?
Yeah, I mean, inside the script tag of a Svelte component, it's just a regular JavaScript module. So you can import absolutely anything from the NPM ecosystem, just as though you were writing anything else. It does have quite a lot of stuff built in that is UI focused that a lot of frameworks don't tend to include. So it has a pretty decent state management system built in. It has helpers for doing animations and transitions, has easing functions and things like that, because a lot of people using Svelte are using it to build user interfaces that are fluid and have lots of motion. And I personally think that's an incredibly important and somewhat overlooked part of UI development on the web. And so it does include all of that stuff, but you don't pay for it unless you're using it. The way that the framework is designed is you only import the things that you need, and the rest of it will just kind of get discarded when you're not using it. And the compiler too will only compile in the bits of the framework that are actually relevant to your application. And so that's one of the ways that Svelte apps don't end up becoming huge, is because everything is kind of optimized for the specific use case to which you're putting it.
So it's working similar to Webpack then? It's able to figure out what pieces are not needed and then just wipes them away?
Yeah. I mean, to put it more accurately, it's generating JavaScript that a JavaScript bundler knows how to tree shake.
Okay, so it's acting as both a compiler and a bundler in a sense.
It's not acting as a bundler. No, there is a one-to-one correspondence between your components and the JavaScript module that Svelte generates. As far as the bundler is concerned, it gets handed a bunch of JavaScript, because that's how bundlers work. They have a series of transformations which take some input code and turn it into JavaScript, and then the bundler's job is to figure out how those pieces of JavaScript interrelate. Svelte does not get involved in it. Having said that, one thing that we occasionally talk about is whether it would be possible to generate even smaller, faster code if Svelte, the compiler, had a kind of a bird's eye view of your entire application rather than focusing on each component in isolation. Because there are certainly times when you might be setting a property on a component that never changes, and because Svelte is only looking at one component at a time, the child component will have to generate code that anticipates that property changing even though it doesn't actually change. And so, having said that there's this one-to-one correspondence and Svelte is not a bundler and it does not take on the responsibilities of a bundler, there may come a time in future when compiler frameworks do start to drift in the direction of having a kind of a more opinionated and holistic view about how your input code should turn into the JavaScript that runs in the user's browser.
Right. It sounds like you could even start to get into the space of something like Node, where you have a package JSON file and you're actually specifying what are the source route files for all of your whole project, so that you could start to build this sort of source tree that you're talking about to be truly, truly optimized in the output.
Yeah, and actually, when you say that, it starts to sound a little bit like Svelte's companion project, Sapper, which is so Svelte is a component framework. Sapper is an application framework that is designed to make it easy to build fairly ambitious applications fairly quickly, including server-side rendering and code splitting and all of the other modern conveniences that people expect when they're building an app. And it kind of does that. It takes the same mindset of trying to generate code that is optimal for your component and generating code that is optimal for your application. It will look at your folder structure, which it interprets as a routing structure or routing structure for the Americans, and it will actually generate a router on demand based on the routes that you have in your application, which is a little bit different to how these things work elsewhere. So yeah, it's a mindset that I think has a lot of different avenues to explore, and we're just kind of beginning to understand what some of those avenues are.
So getting back to the other framework comparisons, just to sort of transition out of Angular, one of the frameworks that seems most comparable to Svelte is Vue, because they're both lightweight, fast, and independent.
Mm-hmm.
So why would someone choose Svelte over Vue given the similarities?
It's a pretty good question. So Svelte has some fairly clear advantages over Vue 2 in terms of performance, and particularly for smaller apps in terms of bundle size. Some of those advantages are going to be less pronounced when Vue 3 comes out, because Vue 3 is actually starting to do some fairly similar things to Vue in terms of compiling Vue components into optimized JavaScript. So it's really, I think, going to come down to a matter of personal preference in a lot of cases. When I look at Vue components and Svelte components side by side, you tend to notice that the Svelte component is quite a bit smaller, because we've developed this, it's basically a language that allows you to express a user interface in the most concise way possible. Vue, because of its history, it doesn't allow you to be quite as concise. So you have to write a little bit more code when you're writing a Vue app. But on the flip side, if you're using Vue, then number one, there are a lot more Vue jobs than there are Svelte jobs. Number two, the ecosystem is much bigger. Number three, it's arguably better supported. It has a larger core team, and if you're stuck with a problem in your Vue app, then it's more likely that you'll be able to find a relevant Stack Overflow answer, etc. So, I prefer to write Svelte code. I'm not going to be switching to Vue 3 because I prefer the development experience of using Svelte. I prefer the priorities that the Svelte project has, but Vue 3 is going to be a really compelling choice, and I think that we're probably going to see definitely at least some movement from the React community over to the Vue 3 community, because I think it starts to address some of the concerns that the React folks have had. And people should be pretty excited about the prospect of having all of these things to choose from.
Speaking of React, React is arguably the largest framework in the front-end space. So while with Angular...
Not arguably, incontestably.
With Angular and Vue, they're really sought as the alternatives if you're greenfielding a project, whereas React is the de facto standard. So for someone who's using React, it's more likely the case that they're being convinced to move to Svelte rather than being on sort of the same plane with Angular and Vue.
Yeah.
If you are a React developer, what are you doing to convince your manager, your team lead to start using Svelte as an alternative?
I genuinely don't know. I'd be interested to hear what people are saying in that situation. I would again point to the source code comparisons. I find that on average, when I rewrite a React component as a Svelte component, it tends to be about 40% smaller. So you're writing code in what seems to me to be a much more efficient way. And when you're writing less code, you're not just saving yourself time, you're not just giving the next person who reads the code less to do, but you're writing a more stable application, because there's a pretty direct correspondence between the lines of code that you're in your app and the number of bugs there are. And this is a thing that applies across languages. There isn't a whole lot of science on it, but the literature that I have looked at suggests that any code base is going to have a certain number of bugs, and that number grows super linearly as code size grows. So if you're using Svelte instead of React, you will be writing less code. your application will probably be smaller, especially if you're using code splitting. It will almost certainly be faster. And you don't have to worry about CSS in JS or anything like that because it's all kind of built into the framework. Same with state management. You don't need to figure out how to use a particular state management system inside your React app because it's already kind of built in. So I think there are some pretty concrete advantages that Svelte has over React. On the flip side, again, there's a ton of stuff that is really, really great about React. The ecosystem is huge. There's so many exciting projects that people are building around React. There's a project called React 3 Fiber, for example, by the author of React Spring. You put those two things together and you can build these incredibly rich 3D WebGL apps using your React skills. We're trying to do the same thing in the Svelte ecosystem, but it's nowhere near as developed because we don't have the benefit of a huge community of React developers all trying to build on top of all of the territory that React has made available. So, if people are building React apps, then they shouldn't feel under any pressure to switch away from them because it's a pretty great framework and it's not going anywhere. But, if you're starting a new project, then I would definitely say take a look at the alternatives because there are some, I think, pretty substantial advantages.
Developers, take your marks. It's time to upgrade your data platform to InterSystems Iris. It's time to deliver complex mission-critical applications in the fastest route possible. It's time to use any data from any source. It's time to embed analytics and create interactive user interfaces. So what are you waiting for? Choose your language, choose your tools, choose your environment. Collaborate, build faster, and deploy more efficiently. Done and done. Tomorrow's next breakthroughs are waiting for you today. InterSystems Iris Data Platform, the fastest way to build applications. Ready, set, code. Start coding for free. Visit intersystems.com/try to try Iris.
Are there any particular use cases where perhaps you're a React developer, you want to try something new, and there are particular performance-conscious cases where you need to really focus on a smaller bundle size or render performance? Can you think of some just smaller tasks that one might be able to sprinkle into an existing code base?
Certainly anything involving animation. React does not do well at animation. That's just kind of a known limitation of the way that the framework operates on a fundamental level because it has to do quite a lot of work for each state change. You're not always going to be able to get everything done inside your frame budget, which is typically, you've got around 8 milliseconds in which to do everything. The React team have kind of said that's not enough time. So instead of trying to get everything done inside a frame budget, we're going to build a system called concurrent mode, which allows you to kind of spread that work over multiple frames, which is incredibly smart and ingenious, and it opens up some pretty interesting possibilities. But it kind of shows that animation is maybe not a big priority. Anything that is for lower powered devices, I would say take a look at Svelte. And when I talk about lower powered devices, I don't just mean cheap phones that are used in the developing world. I'm also talking about things like smart TVs and embedded systems in point of sale devices and stuff like that. People have found that it's just not possible to get the right amount of performance using React in those contexts, whereas they've built the same applications in Svelte and it's been a far more pleasant experience. So that's a niche that we're doing pretty well in, is smart TVs and stuff like that. And even though most web developers these days aren't building those kinds of apps, I think it's probably going to be more and more of the industry over the next few years. I think we're going to see this transition in focus towards I like to call it the embedded web. And that's a place where a framework like Svelte can really help you.
On the other end of the spectrum, so we've got React as the most dominant player. But on the other end, we have these much smaller ones, which are very similar to your space, something like Phoenix Live View, ClojureScript, Elm, these sort of compiled down languages that are inspired by other languages like Haskell or Clojure. How do you see yourself fitting in that space?
I think there's a lot of conceptual overlap between what Svelte is doing and what they're doing. I'm ashamed to admit I haven't really spent any time with any of those things, even though I am deeply curious about all of them. I would say that Svelte is probably targeting a slightly different audience, like the people they're already sold on functional programming, and they really want a system that guarantees that they're not going to have any runtime bugs and stuff like that. Those frameworks are incredibly appealing from that point of view. Something like Phoenix Live View, which basically does all of the work on the server and like ships deltas to the client, and the client has to apply them. That is a truly fascinating concept, but there's a whole class of applications for which that's just completely impractical. So I'm glad that all of this experimentation is happening, but for me, Svelte is the sweet spot between the benefits of the compiled approach that these frameworks are taking and the approachability of something that is based around HTML, CSS, and JavaScript. It doesn't really have much of a learning curve, whereas those other things, you basically got to be invested enough to learn an entirely new language from scratch.
So we've looked at all the other frameworks. We know we want to start sprinkling in some Svelte. And for these bigger development teams, some people actually know React before they know JavaScript. Do you think that Svelte has that same level of approachability where people can just dive right into Svelte without having necessarily to have a background in JavaScript?
So I actually got a really touching email the other day from a chap who runs a coding bootcamp in Egypt, where it's a non-profit that it's providing tuition for refugees from surrounding countries. And he said the kindest thing. He basically said that these people came in with no computer science background and no real experience of web development or anything like that. And they started writing Svelte. And it empowered them to start building things without having to know all of the fundamentals and without having to spend like the first 10 weeks learning all of these idiosyncratic DOM APIs and the ways that they behave differently between browsers and all of that nonsense. They could just start building stuff. So empirically, yes, people are using Svelte in that manner. They are able to build things much quicker than they would otherwise have been. And it's not, I don't think, preventing them from learning the fundamentals of JavaScript. It's just allowing them to get to a point where that is an appealing thing to do, as opposed to that incredibly demoralizing beginner process that so many of us have kind of had to trudge through.
That's incredible. Wow. So if you're not new to programming, are there any tips or gotchas you have for those that are new to Svelte?
It really has, but I'm also trying to figure out if there really are any gotchas. We've tried to make the whole thing as kind of idiomatic as possible so that things are more or less self-explanatory. Definitely some people, when they first encounter Svelte code, are a little bit, whoa, what is this? Because it doesn't behave exactly how you're used to. When you assign to a value inside a Svelte component, you're actually causing that component to update. And that's not something that happens in JavaScript. JavaScript is not a reactive language. Normally, if you change something, you then have to call a function or otherwise do something that causes the page to update in response to your state changes. But Svelte kind of takes care of that magically. And definitely when people first see that, they're a little bit, that's not sure how I feel about that. Similarly, there are a couple of places where in order to get the programming experience that we want within the constraints that we're working in, we've had to kind of commandeer little bits of the language. So the export keyword, for example, we use the export keyword to define the component's interface to the outside world. And it's a little bit backwards from how people normally use the export keyword, because we're saying these are the bits of data that you can pass into this component, as opposed to saying this is the stuff that gets pushed out of the component, if that makes any sense at all. We're also using the JavaScript labeled statement, which is a fairly esoteric piece of syntax that most people haven't encountered. We're using that to define what we call reactive statements. This is code that reruns whenever any of the dependencies of that statement change. So, for example, we use the dollar label for this. If you have a piece of code that is $A equals B plus C, then whenever the values of B and C change, the value of A will also change. Whereas normally in JavaScript, if you have a line that says A equals B plus C, that just happens once. And then after that, you need to manually re-invoke that code each time. Svelte does all of this magic to make the process of building an application a little bit smoother and a little bit faster. But it definitely takes a little bit of getting used to, particularly if you haven't used a reactive framework before. But even in general, like a lot of people come to it and it takes them a minute to get used to it.
I'd actually love to dive into some of this magic now that you're starting to talk about the nuts and bolts of the language. I'd love to just talk more about it under the hood. Starting with a very simple question. Is it all written in JavaScript?
No, actually, the compiler is written in TypeScript. I'm a big TypeScript fan myself. I try and write TypeScript almost exclusively over JavaScript these days, which is ironic because Svelte at present doesn't have good TypeScript integration. If you're writing a Svelte component, then you're writing JavaScript, you're not writing TypeScript. And that's one of the things that we really need to get around to pretty soon because it's one of the most requested features is better TypeScript integration.
Okay, and is the core code of Svelte a compiler in the traditional sense? So it has a parser, a lexer, an AST, all those kinds of things? How is it laid out architecturally?
We do have our own HTML parser. I'm not sure if there's like a technical family of compilers that this belongs to. I don't really have the education to know if we're even doing everything completely wrong. But it basically reads in your markup and turns it into a tree structure, and then at a later phase that tree structure gets walked over and understood and manipulated. The other parts of the AST, the style tree and the JavaScript tree, they're taken care of by external NPM packages, CSS tree for the styles and Acorn for the JavaScript. I would never want to have to write a JavaScript parser because it's a huge, complex language. And luckily we don't have to because brilliant people have already made some packages that make that possible. But yeah, beyond that, I think it probably resembles a conventional compiler fairly closely. But again, I don't really have the background to know the ways in which we're the same or different.
Yeah, and honestly, you had touched on this earlier, building out the abstract syntax tree and comparing the tree of objects within HTML, that it very much is exactly what a traditional compiler is doing. And it sounds like that you are doing this yourself is the big performance draw compared to something like Virtual DOM, because I know in most frameworks, they're building this tree in this virtual DOM to do comparisons. That obviously has a lot of overhead because you're essentially building a duplicate of that tree and doing a comparison.
Yeah.
So how are you achieving those performance gains with your own tree against, not having to use virtual DOM?
Essentially, we're shifting the work out of the browser and into the build step. It's not exactly the same work that's happening, but you can think of it that way. You're taking that diffing process and you're doing it at compile time, essentially. And so the code that gets generated is just a bunch of if statements. If this value has changed, then update this text node. If that value has changed, update that text node. And because of that, the state change is essentially a linear sequence of operations, which is pretty fast to run through. It's the code that gets generated is the kind of code that browsers are good at running.
With all these performance gains, are there any drawbacks? So because now it's a compiled framework, are there things that Svelte cannot do?
There are, in the sense that because components have to be statically analyzable, you can't just put anything inside an expression inside your markup. It has to be something that is going to get turned into text. Whereas with a virtual DOM, there's this really interesting property, which is that your UI is just data and your data is just UI. These things are kind of one and the same substance. And so you can, inside an expression inside JSX in a React component, for example, your expression can evaluate to a piece of text, it can evaluate to a component, it can evaluate to an element, or an array of all of those things, or a fragment, or this, that, and the other. And so you have this infinite complexity in the things that you can build. Whereas with Svelte, you don't have quite the same amount of flexibility on paper. Now, for me, the interesting question is not whether or not you have that flexibility, it's whether or not you have the flexibility that you need to build your application. And so far, we haven't encountered a situation where there's something that you can do in React that there isn't also a very easy and idiomatic way to do in Svelte. So technically, yes, there are limitations because of the language that we've chosen, but in practice, not so much. It's more of an academic question.
Okay, and then are there other aspects of front-end development that can be limiting with Svelte? So for example, the common ones that come up for React or Angular are SEO and accessibility. Mainly because with JSX, you have to make sure that every single property can be covered within that framework. And then with SEO, that's a really big one because of the fact that everything's getting 30 checked. And so you don't necessarily have all of that content available when you're looking at a page. And so Are you also running into these same sort of concerns from people who are using Svelte?
Not so much. So I think these issues are slightly separate from framework choice, because I think all frameworks nowadays support SEO. So when we talk about SEO, I think what we're really talking about is whether or not applications can be server rendered. Because in the model that the web development community has been flirting with for a bit, the single page app model, where you essentially have a blank page and then JavaScript just kind of squirts everything inside that blank page, that historically has not been great for SEO, because historically search engines didn't really know what to do with that. And that's changing a bit. Google is much better at understanding the content of a page after JavaScript has been executed on it these days. But there is still very much a benefit to doing server-side rendering of your application, which is to say sending some HTML to the browser and then augmenting it once the JavaScript executes to turn it into an interactive application. And Svelte is really, really good at server-side rendering, because it's a compiler and it's targeting a different environment. It can just turn your components into basically a set of string concatenation functions. So it's incredibly fast, rather than having to construct the component tree and then serialize it in the way that other frameworks do. So I guess what I'm saying is that all frameworks can, in theory, get SEO done right, but Svelte is particularly well positioned to do so because server-side rendering is so good in Svelte. And Sapper, the application framework that I mentioned, has server-side rendering out of the box. On the accessibility front, I think, again, this is not necessarily so much to do with the frameworks that we use. I think it's more about the quality of the markup that we as application developers are writing, but also the quality of the component ecosystem that you're using. And so the React ecosystem, for example, has some really brilliant component libraries, some of which take accessibility very seriously. And if you're using those component libraries, or if you're using one of the big design systems that are out there, then you're not going to have too many problems, I would hope, with accessibility, as long as you, the application developer, have at least some understanding of what the accessibility challenges are. On the Svelte side, we take accessibility pretty seriously. If you write markup that fails some accessibility test, then the compiler will warn you about it. So for example, if you have an image tag and you forget to add the alt attribute, it will yell at you. And so I think between all of the different frameworks and all of the different techniques that we're kind of converging on, I think as a community we're getting pretty good at solving these SEO problems and these accessibility problems. And I think the common trope of, the hipster JavaScript framework developer ending up writing a web app that is all but useless for people except the ones on expensive iMacs who have no accessibility hurdles or anything like that is really unfair. Actually, nowadays, pretty much whatever framework you choose, you have a good SEO and accessibility story waiting for you.
That's actually pretty surprising to hear, that Svelte is that robust in its compiler and giving its compiler warnings. It almost sounds very similar to the way that you can provide all those configurations with TypeScript. Are you planning on creating a very robust sort of compiler warning system that spans across things simply beyond the framework?
Not beyond the framework. I mean, we're really focused on making sure that your components are written as well as they can be. But this is one of the great things about being a compiler, because we're not shipping this code to the browser, because it all just lives inside your node modules folder. We can include features that other frameworks would balk at. And accessibility warnings is one of those things. Like it just wouldn't occur to you to include accessibility warnings in the core of a framework.
Right, and that's exactly what surprised me. Right, yeah. And that's a good thing, though, I think. I think we need to have more of that available to developers so they can be aware of these things. Yeah. So are there other aspects of the framework for your compiler warnings that you're also including? If you could just run through some of those, it'd be cool, because I didn't realize that accessibility was one. Are there others similar to that, like in performance?
I think that's the big one. Certainly we have things like unused property warnings, unused CSS selectors is another big one. Because the styles in your component being looked at in the context of the markup for that component, we're able to say that, this selector over here, you've got some styles for the selector, but you're not actually using that selector anywhere in your markup. So you should get rid of it. And at the same time, the compiler will itself get rid of it so that you're never actually shipping any unused CSS to your users. That is another pretty neat feature that you can't really get without a compiler. And I guess there are probably some ways that we could maybe figure out ways to have performance fine-tuning tips emitted by the compiler, but that's it's not something that we have currently.
Are you getting a lot of performance gains from that unused CSS? I feel like in this front-end community, that's the biggest one. Everybody feels like that's a super hard problem to tackle, but if you can get that right, you can save so much. I mean, so many pages, if you look at them through like Google Lighthouse, they'll say that you're not using 99% of the CSS that you have bundled up. So is that actually helping application developers with that feature?
I mean, I think it must do, but I've had this experience so many times where, before Svelte, I had this experience so many times where I would write some code and my colleagues would write some code and we weren't sure what the CSS that the other person had written was doing. And you don't want to delete it because it's so hard to tell what effect a piece of CSS has because it's all inherently global. And so you have this phenomenon of the append-only style sheet, right? You never delete CSS. You only ever add to it unless you get to the point where you've realized that you've got 200 kilobytes of the bloody stuff and you need to start over. Because styles in Svelte are component scoped, you just never reach that problem. And so I think it's probably fair to say that a Svelte app will typically have less CSS than most apps, purely by virtue of the fact that you're not writing anything that you don't need.
And then I also want to just touch on this lightly before we move off the framework internals. So you had mentioned this earlier. Testing is another big one.
Yeah.
How is it tested? And are bugs introduced by the compiler?
Are bugs introduced by the compiler? Yeah, I wish I could say that they never were, but all software has bugs. And there have definitely been times when we've released a new version of the compiler and it has introduced bugs into people's code. We're usually pretty good about fixing those quite promptly. But yeah, I can't claim that we're perfect in that regard. Testing, it's kind of like testing anything else really. Because the compiler is just turning your component into a JavaScript class, you can test it in the way that you would test any other JavaScript class. I think this is something that we've been criticized for as a community. We don't have a really opinionated solution around testing. Like we don't have inside our default project template like a boilerplate that you can just kind of start filling out with your own tests. And the reason for that is that we haven't really figured out what is worth testing in this context, because so many people, when they start writing tests for their user interface, are essentially just recreating the tests that already exist inside the framework's own test suite. Svelte has thousands of tests, and the idea that you need to check that if you pass in the number 42 as one of the props to your component, then the number 42 is the thing that gets rendered inside the DOM. It's like, what value does that bring? So, I guess we'll figure that out as more and more people start yelling at us about the lack of an opinionated testing story. But in the meantime, it's just JavaScript. You can test it however you like. It works with any testing framework. People use it with Jest. People use it with Mocha. People use it with, Svelte testing library from Kent Dodds' suite of testing libraries. There are ways. There's plenty of ways.
So switching gears, I noticed that back in April you released version 3 of Svelte.
Yeah.
How was it received? What are the big changes that were part of version 3?
It was received incredibly well. We really stuck the landing that time around. We've been working on it for a very long time, and we've been kind of talking about it in our own community and hyping it up, and people were starting to get excited. But it was at that stage the Svelte community was very small. But then in April, it was sort of a confluence of things. We launched version 3. There was a video from a conference that I'd attended where I'd spoken about Svelte in Israel. You Gotta Love Front End, which is a really wonderful conference. There was a podcast episode and there was a blog post. All of those things kind of came together in the perfect Hacker News launch post. And so for the people who like to read about stuff, they could read the blog post. People who prefer to listen, they had the podcast. People who prefer to watch videos about this stuff, they had me standing on stage in Israel waffling for half an hour. And so because of that, I think we kind of hit all the different targets simultaneously, and we kind of generated this wave of hype, and we've been riding it ever since. It was really good. Not really through any kind of planning. It was all just very fortuitous. And I don't know if it's something that we'd ever be able to repeat, but it really worked well for us. The big change was really around the developer experience. We essentially redesigned the component authoring experience from the ground up. Before that, we'd been constrained by some bad API design decisions that I had made in the very first version of Svelte. And for Svelte 3, we really kind of said, what would happen if you were to design the component authoring experience from scratch? What would it look like if you just threw away all of the constraints that you normally have to work with when you're designing a component framework? And Svelte 3 was the result of that. I should say it was very largely inspired by the release of React that included React hooks, because that kind of changed people's perceptions of what authoring could be like. Writing a component with React hooks is much nicer than writing a component with React classes. Svelte 2 we thought was nicer than React with classes, but React hooks kind of raised the bar, and we wanted to try and clear that bar.
I think that's a great point that you touch on here, which is that, and you also touched on this earlier, you don't need to necessarily see these frameworks as adversarial or in competition of each other.
Definitely not.
Like you just said, you were inspired by it, so it's helping. Every single group is getting lifted up because of the changes they're making. So they're all pushing each other to help the web move forward in the right direction. And so that actually makes me think, you had said earlier that Vue 3 is going to be a very big release because it's going to provide a lot of the features that people are looking for in these sort of smaller frameworks. Is there anything from Vue 3 that you're seeing that's now getting you more amped up for the release of Svelte 4? Like, what are the things on the horizon that you're seeing from these other frameworks that are inspiring you?
Well, Vue has always had really good TypeScript integration, or not, maybe not always, but for a long time it's had really good TypeScript integration, and I definitely want to steal that at some point. The other thing that I'm looking at quite enviously is React Suspense, which is not yet stable, but a lot of people are talking about React Suspense and the thing that that's going to enable, which is to make it much easier to deal with asynchrony in components. At the moment, it's quite easy to build an application that has a bunch of loading spinners, for example, or flickering when you switch between tabs if something needs to be fetched over the network. And the React team have really been focused on solving that problem because it affects the product that they're using it for, Facebook. And so that's something that I would definitely like to look at stealing. But you're right, all of these frameworks do learn from each other a lot, and I genuinely believe that a rising tide lifts all boats. And it's kind of funny when we see people on Twitter doing the whole framework war thing, and like people are fanboying over their particular thing, because the reality is we're all kind of friends to a large extent. Like I was in London a couple of weeks back, and I managed to get a pint with Dominic Ganaway and Sunil Pai on the React team, and we're all kind of just sharing ideas back and forth, and it's very collegial. So yeah, that's one of the nice things about working on the web, I think, is that people who are natural competitors do feel like it's appropriate to share ideas and share notes and really try and solve these problems from different angles, but ultimately we're all trying to solve the same problems, and we're all ultimately on the same team. It's nice.
With all that inspiration for the next version of Svelte, do you need help with any of it? What's the best way for someone to contribute to the project if they're new to open source, or if they're a seasoned vet but they want to help contribute to Svelte?
Oh wow, with our issue list is pretty substantial at the moment. We definitely do need some help triaging things, but it's a little bit of a difficult code base for someone to kind of dive into on a whim. But if people are motivated to get to grips with the code base and understand how it works and start helping to merge pull requests and close issues, then they should definitely come by our GitHub organization, which is github.com/SvelteJS. They should come by our Discord chat room, which is svelte.dev/chat, redirects to a Discord server. And start talking to us about what they could bring to the project. Everything is volunteer based. We don't have like a formal team structure. We don't have a corporation behind us. Everything is kind of done on a best effort basis, which we like. We all have lives, and everyone is by the same token welcome to come and be part of the project.
And we'll make sure to link to those URLs in the show notes after the show. Rich, is there anything else you want to touch on? Any other closing thoughts?
No, just that, this is a really exciting time, I think, to be a web developer. We're kind of in a place now where we can start to think seriously about what we want the ideal experience of using the web to be like. And we can start building tools that start to make those experiences possible. And, I'm glad to be a web developer in 2020, even though the web is sometimes a difficult platform to work for. I don't think there's anything quite like it.
Rich, it was a pleasure. Thank you very much.
Thank you.
Developers, take your marks. It's time to upgrade your data platform to InterSystems Iris. It's time to deliver complex mission-critical applications in the fastest route possible. It's time to use any data from any source. It's time to embed analytics and create interactive user interfaces. So what are you waiting for? Choose your language, choose your tools, choose your environment. Collaborate, build faster, and deploy more efficiently. Done and done. Tomorrow's next breakthroughs are waiting for you today. InterSystems Iris Data Platform, the fastest way to build applications. Ready, set, code. Start coding for free. Visit intersystems.com/try to try Iris. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.